Let's go. Oops, I just realized I wasn't there. It's playing with kids. What we're going to do today is look at some inequalities, look at a couple of questions and go through it. So one of the main thing with the inequalities is just in terms of when we're interpreting linear inequalities, cannot exceed, must exceed, no more than, at least. So we'll look at this, that most of the time you'll just use these two, like no more than or at least. Notice that is equal to, okay, where these ones aren't equal to, so it cannot exceed, must not exceed. So for example, you know, not exceed 3. So x needs to be less than 3, but what we say is like, you know, you can say whatever this is cannot exceed 3. Whereas if it was the other way, if I get there, that needs to exceed 3. Okay. Whereas if we have something like this, the equal symbol, which I don't have, let's just say it's that one. That needs to be at least 3, because it can be higher than that, but at least it can be 3. Whereas if it's the other way around, whatever word you've got there, that can be no more than 3. It can be anything less, but it can't be more than that. So just a couple of words when you're interpreting these, because you will find that you'll need that and to refer to that, and that will help you when you're interpreting those, which is what we're going to look at today. So we're just going to have a look at a couple of examples here and just look at how it is, how we use that in words. So I was happy to go at this one. The company, so this is just a question, it continues on. So the company also produces, so there's a company that we've looked at and it produces 2 types of hockey sticks, flick and jink. Let X be the number of flick hockey sticks that are produced each month. Let Y be the number of jink hockey sticks that are produced each month. Each month, up to 500 hockey sticks can be produced in total. So I'm just going to copy this and put this into Word. Actually annotate this and do that. So, okay, it's not going to do it for me because my Word has been playing up. I won't copy it. So we know that X is flick, Y is jink. Each month, up to 500 hockey sticks are produced in total. Inequalities below represents constraints on the number line, each hockey stick that can be produced each month. So constraint 1 is just showing that, well, you know, at look at the wording that we used, at least 0 hockey sticks is made. I mean, you can't make any less than 0. So it kind of makes sense that you can't, you know, make at least 0 hockey sticks. Flick hockey sticks would be made, where at least 0 hockey sticks would be made there. Constraint 3 is X plus Y, which is the number of hockey sticks of flick plus number of jink hockey sticks, needs at most can be 500, because each month up to 500 hockey sticks in total can be produced. So I've interpreted the first 3. What do you think constraint 4 is saying? Interpret constraint 4 in terms of the number of flick hockey sticks and the number of jink hockey sticks produced each month. So this is kind of like what we did last lesson, but the other way around. Last lesson, we're trying to interpret worded questions into this. Now we're trying to go from an inequality into worded scenario. So this is why my, I suppose, little hack kind of helps, but we'll have a look at this and we'll have a look at an example. So first of all, we've got realized no more than, okay? So we've got that one there, which we can look at as no more than. So let's look at that. This is an exemplar response. the number of jink sticks produced each month must be no more than twice the number of flick sticks produced each month. So we have, let's pull this out into Word actually. That is my exemplar response from Y. And where we have Y is jink. The number of jink sticks produced each month must be no more than twice the number of flick sticks produced that month. Number of jink sticks produced each month must be no more than twice the number of flick sticks produced each month. Because if you think about it, if we produced 100 flick sticks, right? If you produced 100 flick sticks, the number of jink sticks you can produce is no more than 200. Hence, the number of jink sticks produced each month must be no more than twice the number of flick sticks produced each month. So you can put numbers in to help bring that. So the way I would tackle this is really go write down the inequality, make sure you put the actual words or the sticks what you're trying to interpret. And then from there, we can use this word as no more than, and we read from left to right with these things. So the number of these can be no more than twice the number of those. If this was a half, the number of jink sticks can be no more than half the number of flick sticks produced each month. So that's how we can actually do that. So I will put this one as a bit of a screenshot for you guys, but a bit of an exemplar response. I think that one's a good one, how to interpret that one. I will stick that up on our lesson plan for us a bit later on. Examiner's notes on this. So you'll notice when you read exams, there's these things called examiner's notes. So that's where they're pretty common, I suppose, common answer or misconception students have. And you'll find that when you start getting through examples of exam responses. And this examiner note said reference to an inequality was expected, such as no more than. So they really wanted that they wanted you to refer to the inequality such as no more than. This question was not well answered, often with flick and jink reversed in the sentence. So a lot of people stuffed it up because they kind of did that hack before where they go, oh, I should make that too. So, and do the other one with flick. But again, it makes sense how it is here. Just to go back over some of the things that we looked at before, remember when we're graphing an inequality with a region, if it is got these symbols, it's going to be with a solid line. If it's got these symbols, okay, without the equals, it's done with a dashed line as well. Okay, let's get into the rest of it now. Okay, one I want to look at. Okay. Let's go through some of these questions here. So I thought we'll just go through a couple of these questions just to see how you guys go. Give you a little bit of time to answer these, but I might just go through these as well. Okay. Sorry, my daughter is running around crazy. All right. Okay. A point that satisfies the inequality of this. How are we going to answer this one here? What you really want to do is, I mean, you could rearrange the equation and see what it is. Probably the easiest way, you could graph it as well, or you could just put the points in. If you put the points in, you know, it's going to be 3 minus 10 is greater than or equal to 12. You know, that's not going to be right. So I've literally just substituted 1 in for x, 5 in for y. So I know here that I need a bigger number for x and a smaller number for y. So that's not going to be it. That's not going to be it. That's not going to be it, because that's going to be like 9 minus 6. Let's try this one. So I reckon it might be that one. So 15 minus 2 is greater than 12. Well, that's going to be correct. So straight away from the first one, what I did here is I realized, hang on a moment, this is going to give me a small answer, and that's going to, I'm taking away like a number that's going to be bigger. So I just jumped straight to the bottom there rather than going through them all. So there, you can actually just see a point that satisfies inequality. You can just substitute them in. The three inequalities below were used to construct a feasible region for linear programming. The point that lies within these feasible regions is what? Now, again, there's two ways you could do this. You could graph these, okay? Or you could try and see which one goes through them all. I know x needs to be less than 3. It can't be that one because it's not equal to 3. I know y needs to be less than 6. It can't be that one, and it can't be that one because it's not equal to 6. I now know that x plus y needs to be greater than 6. Which one do you think it is? That one there. That equals 6. That equals 6. That one there. So you can see by actually looking at these points and elimination, sometimes elimination is a better strategy to tackle these. If you went to graph these, it would take you a lot longer. If I went through this and kind of just said, okay, I know it can't be that one, that one, that one. Sometimes you might be ended up with 2 or 3. And then if I went with 2 or 3, you might substitute those in to see which one suits all of them. But elimination strategy is pretty good for multiple choice. So that's how we can read through those. Simon grows cucumbers and zucchinis. Let x be the number of cucumbers that are grown and y be the number of zucchinis that are grown. For every 2 cucumbers that are grown, Simon grows at least 3 zucchinis. An inequality that represents this situation is what? I'd like you guys to have like 2 minutes just to have a crack at this one for me, please. Oh. Feel free to put your answer in online. How did you go? You got your answer? If you do, put it on chat. I'd be interested to see how you're going. You obviously need a bit more time, or you're just completely burnt out. Okay, so you can use a bit of the hack for this one, which is what we did last time. For every 2 cucumbers that are grown, Simon grows at least 3 zucchinis. So I'm going to do 3 cucumbers, 2 zucchinis, because I'm doing this 2, I know goes with the zucchinis, and I know the 3 goes with the cucumbers. As I said, it's a bit of a hack, it's a bit of a workaround. I don't like it, but sometimes it does work. And then we've got to look at the inequality, at least. Now, if we go back to our little one here, at least. Okay, I believe it's that way. Let's have a look how we go. An inequality that represents the situation below. Oh, hang on. Let x be the number of cucumbers, 3x, and y be the number of zucchinis. It might be like that. We'll see how we go. So then I can rearrange in terms of y, because these are all written in terms of y. Divide by 2. Let's see if we got that one right or not. 3, going with E. Don't forget on these worksheets, we do have solutions for them all as well. So it's always good to check your answers as you go through. Then it'd be good if you actually get to the answer section. E. There you go. For every 1 cucumber grown, Simon grows at least 3 zucchinis. I suppose you could say it like that, couldn't you? So how do we do that? Is, if you think about it, for every 1 cucumber grown, so if I put 1 cucumber in, I'm going to make at least 3.5 zucchinis, because that would be y. I'm going to have the number of zucchinis is at least 3.5, 1.5, which kind of makes sense because if you halve this, for every 1 cucumber that's grown, Simon grows at least 3.5 zucchinis. And that kind of makes sense. I personally prefer my hack method and then using this terminology as well to help you with it. So I kind of put the number on the other one and do that. Alternatively, we know that y is the number of zucchinis. We know that x is the number of cucumbers. Okay, for every 2 cucumbers that I've grown, there are 3 zucchinis. So I've got this straight line, and because it's at least, it's going to be that way. And if I think about it, for every 2 cucumbers that are grown, if I grow 2 cucumbers, at least 3 zucchinis. So my feasible region's up here because I can have more zucchinis. I can have 2 cucumbers and I could have 10 zucchinis, right? Because I need to have at least 3. So I know that this is my feasible region. So now I can do y equals mx plus c. I can see that my gradient is 3 on 2. So I know that my equation is y, and I know y needs to be, like, it's bigger then because it's going up that way. Otherwise it'd be the other way. What do we got? Rise on run. So it's going to be 3x on 2. So again, from the graph, you can get the equation from that as well, just by plotting those out, figuring out where your required region was. If the required region was under there, so it'd be like for every 2 cucumbers that are grown, Simon grows no more than 3 zucchinis. Then if that was no more than, again, go back to here. No more than would be the other way. If it was no more than, that means, well, if I grow 2 cucumbers, I could grow 1 zucchini. It said no more than. And then the inequality would switch around. And that's sort of how we use it. Hence, at the start of the lesson, guys, please make sure you have these definitions written down. They should be in your reference book. You may need to refer to them. I know I always need to refer to them. So it's really important that we do, refer to those. How did you go? Did you get E? Maybe you did, maybe you didn't. That one's a tricky one. A childcare centre requires at least 1 employee for every 15 children enrolled. A childcare centre requires at least 1 teacher for every 15 children enrolled. Let X be the number of teachers employed. So X is the number of teachers employed, right? And I'm going to put 15 because it's that hack that I'm talking about again. Okay. And Y be the number of children involved. So Y, and I'm going to have 1 on the Y. Childcare centre requires at least 1 teacher, okay, for every 15 children involved. So it's at least is that way by memory. At least, other way. See, I always forget. So hopefully you guys can actually put it on your. So it should be that one there. A. Or should be A. Let's see how we went with the answers. 3, 4 will be up here. D, I got that wrong. What did I do? D, 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 D. All right, gotta scroll up. Let's see, what did I do wrong there? One teacher. All that stuff up there. Childcare is at least one teacher for every 15 children enroll. Let me do my graph of it. So if I've got teachers is X, so it's going to be 1, and Y is children, X is teachers. That's why I prefer the graphing method. I always prefer that one rather than that, but it should work still. Okay, so I know that's going to be X is teachers, that's going to be 1, 15. So my gradient on this is going to be Y equals rise on run. What they're saying is D. I got my inequality around the wrong way. Let me check. Did I not read at least? Anyway, I'll go with this and we'll have a look. So I need at least one teacher for every kid. So I could have 2 teachers. I can't have for 15 kids, you know, so I could actually, it could go up this way and that way and that way. So if the Y is going bigger, that means it should be this way. Should still be that way. I'm getting the same answer as A. Let me double check that. Let's put in some numbers to check because I can have 2 and 15, right? I could have 2 teachers for every kids. So let's see if that works. So if I've got 2 teachers, that's going to be, what have I got? X is 15. I do have it around the wrong way. So 2, 15 times, oops, no, that should be 15, sorry, because it's Y is 15. So it should be, if I substitute the 0.215 in, which makes sense, we've got 15 for Y, should be greater than or equal to 15 times 2, which is incorrect. So I do have my inequality around the wrong way. Why have I got my inequality around the wrong way? Which means it is D. And that's why it's always good to put in a test point to check that rather than jump to conclusions, which is the second step that we should always do. So, what do I say? Childcare is at least one teacher. So the difference here between these, for every 2 cucumbers are grown, Simon grows at least 3 zucchinis, right? So when it's written in a format like that, you'll find your hack will work pretty well. But at least 3 zucchinis, okay? When it says at least 3 zucchinis, notice that the inequality is that way, attached to the zucchinis. So at least zucchinis. So what I need to do here is it says childcare centre requires at least 1 teacher. Now see, that's put together. So really what I need to do is at least is done to my teacher, therefore it needs to be that way. At least that way. So when you see the at least, should be sort of, I suppose, at least did it that one. So that's why I've actually got that around the wrong way. So you need to be a little bit careful with that, that the at least, and then what the second word comes with will be pointing that way. So if you've got that, I need to actually do at least and then teachers. So I could rewrite this as this way. For every 15 children enrolled, at least, where am I? For every 15 children enrolled, at least 1 teacher is employed. So if you are using that hack, make sure it is in that way. Otherwise, it will go a bit wrong. So you can rearrange that, but this at least da-da-da is actually associated to that one. So if I've rewritten that, then I can use that hack. For every 15 children enroll, X is the number of teachers employed. So I can actually do 15X. Then I can do at least one teacher is employed. That would have actually got me to my answer there, which would have given me D, which is what we're looking for, right? Because that is the same thing as D. So yeah, just be careful of that when you are using that at least. The at least is going towards one teacher, which basically means if it's at least, your inequality needs to be well, open to the teacher, I should really say, because X is a teacher, which would be there. All right. Also, another thing you really can do too is use a test point once you've done it. Again, so a test point is really good to use these. Make sure you find something that's in the actual feasible region, not on the line. Something that makes sense. So I can have 2 teachers for 15 kids. Correct. I can then put that in the equality and see which one works. So if you're sort of confused between the two and you're not sure which way to go, if we actually put it in this equation, where if we put 2 is the number of teachers employed, okay, X is the number of teachers employed. If I put 2 into here, that's going to give me 30, right? So for this, you're going to get 30, and then Y would be 15. And you can see that that is false, okay? But we know this is true, so it can't be that equation. We know it's going to be this equation, so it could be that one as well. If you're getting confused with the inequalities, same thing when you make them, just choose a test point and do it. So I know X is the number of teachers employed, so that's 2 for X, so that's going to give me 30 this way, and Y is 15. That is true, therefore that's the correct one. So when you make these inequalities, just be careful, like what I did, learn from your mistakes if you do make them as you go along. And one thing you've got to be careful of, usually most people get them correct, but they stuff up this inequality a lot of the time. So the important thing to do that is use a test point, okay? So we want to use a test point. To make sure, correct. And if it works, then it's good. And the test point needs to be in the region. So when we get to those, that would be my number 1 tip for you guys to help. Any questions on that? Okay, no, you guys are all silent. This year, Robert's planning a camp trip for the members of his gold prospecting club. So we're going to move into a bit more of the feasible region stuff here. We might get through 1 or 2 of these and then we'll sort of end it there. The club has chosen 2 sites, Bushman's Track and Lower Creek. Let X be the members staying at Bushman's Track. Let X be the members staying at Lower Creek. Okay. I do not want to do this one. Sorry. I'm going to skip that one. I'm going to save that one for another lesson. This is the one I want to do. I'm going to start again. An event involves running for 10 kilometers and cycling for 30 Ks. So we have like this triathlon, not triathlon, but an event. Let X be the time taken in minutes to run 10 Ks and Y be the time taken in minutes to cycle 30 kilometers. So I would always be like, okay, Y, time for cycling. So I would be like, just, T cycle, time run. I mean, it says it here anyway, so that's fine. Event organizers set constraints on the time taken in minutes to run and cycle during the event. Inequality 1 to 6 below represents all time constraints on the event. So we've got X has to be greater than or equal to 0. So if we go back to our sample, at least, X needs to be at least 0. So in other words, we're saying X is the time to run needs to be at least 0. Well, that kind of makes sense. Like if you go for a run, you can't do negative minutes running. Like you can not run and that's 0. You can't, like if you run, that's the quickest time you could do it in would be nothing, but you just get straight to the end. We can't go back in time. Time to actually cycle, well, would be at least 0. So we have those constraints. Those constraints are actually running along here. So that's, would be x equals 0, y equals 0 would be here, and that means this is all my feasible region. That's all my feasible region there. We've got x here, so we've got the time to, so now we want to explain the meaning of inequality 3 in terms of the context of this problem. Again, when you need to interpret these, all we need to do is just look at what x is. X is the time to run. And then at most, no more than, sorry, not at most, can be no more than 120 minutes. The time to run can be no more than 120 minutes, which is going to be x equals 120, which would be along there, I would say. Because x needs to be less than that, right? So you can't run no more than 120 minutes. The lines y equals 150 and y equals 0.x are drawn on the graph. So we've got that, and we've got that. Sorry, x 120 will be over here. I did too much to talk about that. All right. On the graph above, draw and label the lines x equals 120. Now this says equals 120, okay? So you need to draw that. So you could do this on your CAS, but obviously if it's an x equals, we know it's going to go straight through here. So you'd use a ruler. This is why you've got to bring a ruler into your SAC and into your exam, guys. I know I don't have a ruler on me. I'm trying to use a stylus, but if you did this, you'd lose marks. So bring a ruler in. It does say draw the lines. It doesn't say draw the inequality. Because it's a line, we can actually do it as a solid line. Now, if it said do the inequality, that would be a bit different. And notice it says draw and label. Drawn, labeled, okay? And y equals 1.5x. So 1.5x, if you think about it, it's got a gradient of 1.5. If I put in 100, it's going to be 150. So I know it's going to go through that point there. Use a ruler. You would here, and this is why you need to bring a ruler. And a straight line through there, and you should be right. And we're going to say y equals 1.5x, okay? Clearly shade the feasible region represented by inequalities 1 to 6. Now you could do this and test all the regions. Personally, because this is an extended question, this is where you'd get out your CAS. So can you guys get out your CAS for me? We're going to draw this one together. And this will be the last question we'll do. I should just click here. I always forget to say. So if we're going to go to graphs and table. Now the first one is x is greater than 0. So you'll know what you need to do is you actually need to change it up here and go to x, and we're going to choose the same symbol. Double check once you put it in that you've translated it and it's the correct way. If it's not, it's going to stuff it up. I would then personally, then you can change the next one to this one, and we're going to put in 0 and hit execute to that. Where are we? So we're just doing this question. So the next one is x is less than or equal. So grab out your CAS. We're going to do x is less than or equal. We're going to put 120. Then we've got y is, so we're going to go up here, change that to y. So we're going to graphs and tables, 150. Y is 1.5x. And then we've got y is, let's just say 0.8x. Now I'm going to make a mistake here, just to show you how you can change it. There's two ways you can change this. You can either delete your equation, or you can actually double tap on this, and then I can just change that. So with your stylus, if you guys just double tap on the inequality, you'll notice it brings it up. Now you can't change it from y to x, but you can change it if you put it in the wrong way. So I'm just going to double check I got everything correct. That's good. So I'm looking here and I'm looking at the question on the screen. That's the same way. That's the same way. That's the same way. That's the same way, and that is correct. So I'm looking at the inequality, and I'm going, yes, it is equals 2 on that, and I'm looking at also the numbers and x. I'm going to graph that. Now, don't forget, I think Ed Rollo does it silly. They do it as intersection, as union. Don't forget, you need to change this from intersection, from union to intersection if you haven't. Once it's set, it should be fine. We're now going to graph that. You'll notice it will show us. What we do want to do is we're given a scale here from 200 to 200. So we're going to change our scale to be the same as that. So we're going to actually change our view. It's the wrong one. Let's go from like -10, just so we've got a bit of room, to maybe 210. And we're going to scale it with, now this scale goes up by what? 5. So well, let's do the scale as 5s, just so we've got the same thing. This is probably one of the important parts doing the scaling that a lot of people miss out on. Why? Because when you're transferring the information across, it's going to look exactly the same. We're going to do our scale again as this is going up in 10s, so we're going to do our scale for y in 10s. So you know on our x, -10 to 210. We are going a little bit beyond because we want to be able to see it. Otherwise, the top of the screen will be at 200. So we're sort of going to 210 to -10. We're changing our scale on 5s because it's like 5, 10, 15, 20 for the x's. On our y's, though, we're going to go 10, 20, 30, 40, 50. So it has a scale of 10. So again, we're starting at -10, going to 210, scale of 10. And we're going to change the dot just to 1. Hit OK. Now I've got a similar scale, as you can see. So if we resize that, if you hit your resize button, it's a pretty similar scale to what we've got. If I hit the resize, though, you will notice that your y will change. So again, your y has changed there. So you might want to go to like -10 to 200. So you probably want to resize first, draw it, and then scale. And you can see now that's probably a bit better with what we're looking at. So it did say shade in the equality region. So clearly shade in the feasible region. Now it says shade, okay? So you will want to actually then literally color this in, you know. I would probably not color it all in though, like that. Personally, I would just get my drawing tool in the exam, and this is basically what you will be doing in the exam, and in a SAC for doing that face-to-face, is just do this, or, you know, maybe not vertical lines, but could be, you know, slightly on the side, maybe. That's what we should have done. I'm going to do it both ways. I would just do it one way. Let's just go with that way. So, and it should go pretty much line to line. Don't have to color the whole thing in, unless, you know, you really like art, which a few of you guys do. Then the important part is that's done. But what I would do here is I would just do a quick key and then just do a quick F.R, or you can write feasible region. It didn't say to do that, but that just helps you correlate it, okay? So we're done. So we've drawn and we've labeled the lines, which is 2 marks, 1 for that, and I've labeled it. I've drawn this and I've labeled it, and I've shaded that in, okay? So you can see that that's 2 marks there, and that's 1 mark there for coloring it in. To color it in, all we really need to do, guys, was just make sure we put this in our calculator, make sure we got our calculator set up right, and then just literally color it in, right? Not too bad. So one competitor, Jenny, took 100 minutes to complete the run. Between what times in minutes can she complete cycling and remain within the constraints set for the event? So if she took 100 minutes to complete the run's down here. So if you look at that, she needs to be between here and here, right? That's what we're thinking, okay? So what are those constraints? Well, what we can do is on our CAS, we can go analyze, G-solve, and we can actually do we want to do a Y-calc, and we want to do it when X, and see my lines flashing? I don't want to do it for that. So I'm going to cycle through these. And now this line's flashing, okay? Normally you do this pretty quickly. I want to do this one and that one because I can see it kind of goes through there. So I'm going to hit execute on that, and I'm going to say, hey, when you run 100 minutes, what's my Y value? So it's 150. So I know the maximum is 150. You could read it off the graph, but sometimes you probably could have seen that the equation, if you put 100 in here, it is 150. So you do know that's the case. That's the other way to do it. Or you can read it off the equation. So there's two ways you can do it in the CAS, or if you know which inequality it is, you can just put in 150 there. The problem here is, though, it's not just putting it into this inequality, it's also looking at the other inequality restrictions, because that is 150, but this inequality also says it is equal to 150. So because it's equal to 150, you can actually have it there. If this was less than 150, then the times to answer this would have to be, so I know she can equal to 150. So what times in minutes? So I would have T. So I know the most she can have is 150, and it can equal that. Why it can equal that is because we have two constraints. We have this constraint, which is equal to it, and also this constraint. It's actually the intersection of those both points. And because they're both equal to that, it's within it. If one of them wasn't equal, just say if that one was less than 150, then it actually, my answer would have to be less than 150. So we've got that answer there. And then I also want to find out, so now I'm just going to go analyze GSolve. I'm also going to do a YCalc, and I want to then just quickly scroll through my graphs by pressing down, down, down. I want to get this one, hit execute, and I want to find out when it's 100, which I know it will be 100 because that's the equation. Sorry, it will be 80 because it was 0.8, wasn't it? It wasn't 1. Yeah, it's that one. So that makes sense why it's 80. That is also equal to, but notice it gives us that. It's a solid line. Because it's a solid line on here, we know it's equals to. So your answer for this would be this one. Okay, now I'm just going to show you if it wasn't a solid line, what that would look like. I'm just going to change up the question slightly. Go away, come on. Change that one. Okay, so I've changed that. Just going to quickly graph this again for you guys. So see, it's a dotted line, right? And then if you go analyze GSolve X, Y calc, if you do Y calc, and I'm going to scroll through till I've got that equation, and it also tells me what equation it is, so you can always sub it into that equation. But if I now put in 100, it will tell me 80. You still get an answer, right? But because it's a dotted line, I've got to recognize that it actually wouldn't include that. Okay, in this scenario it does because it's an equals line, but if it wasn't, that's what it is. I don't really see that. They're normally equal to, but I'm just pointing that out just so you guys are a bit wary of how these inequalities refer to that. So if she took 100 minutes to run, she can either cycle in from anywhere from 80 to 150 minutes to still make sure she's finished that event in time. So competitors who complete the event in 90 minutes or less qualify for a prize. Tiffany qualified for a prize. Oh, good on her. And the question goes on. Determine the maximum number of minutes for which Tiffany could have cycled. Determine the maximum number of minutes for which Tiffany could have ran. This is moving on to the next section, okay, which is a bit different, but I'm going to quickly go through it. If she completes for an event, she has to complete it in 90 minutes or less, okay? So that means if you complete it for 90 minutes or less, you can kind of, you know, if it took you 60 minutes to run, that means it would be 30 minutes, right, to cycle. So we've got to find where 90 minutes is. So we could do 40 and 90, which would be good. We could also, which would be here, we could also do 20 and it would be 70 minutes, which is here. If it was 10 minutes, you'd be having, these are 50, 60, 70, 80, 90, sorry. If it was 10 minutes, it would be 80. I did that wrong. If it was 20 minutes, it would be here. Is that 60, 70? Yep, that would give you 90 minutes. If you did it in 90 minutes to run, you'd need to cycle in no minutes, right? If you did it in 80 minutes, it'd be 10. Hopefully you can kind of see what's going on here. 70 minutes, it would have to be 20. 60, it would have to be 30. 50, it would have to be 50. So you actually have this straight line. So you have a constraint, right? You have a new constraint that you've made. And if you think about that constraint, that would be 0, 90 here, and that would be 0, 90, 0 here. The equation of this line is going to be y equals negative x plus 90. So you can figure out that equation there. She needs to complete the event in 90 minutes or less. So she needs to have a y value of equal to less of that equation. So let's put that in there. And then what we can do is it asks for what is the maximum amount of minutes which Tiffany could have done that. So we're going to have to put a new inequality in from that. So I can see that the inequality of that is negative x plus 90. We graph that, you'll see, and I should know it makes sense under here. So otherwise I got my inequality around the wrong way. So I'm just going to let my CAS sort it out. No, I've got my inequality around the right way. So now I'm going to change up my zoom. I'm just going to look at a different area quickly. I'm just going to sort of go from like, I don't know, 100, 90, 90, 90, something like that, just so I can look at it a bit better. Okay, there we go. So I should have this straight line coming across the inequality, which makes sense, which is beautiful. So now I want to know the maximum time that she can run the event and the maximum time that she can run the event and maximum time that she can cycle. That's the maximum time that she can cycle. That's the maximum time she can run. I think that's what the question was asking. Determine the maximum number of minutes which Tiffany could have cycled. So she could have cycled, which is, we're looking for what the cycling is on this y-axis. That would be a maximum time there. I can read it. So I want to know what that intersection point is. So I'm just going to go analyze gsolve. I'm going to do my intersection, and I want to do the intersection between, if you scroll through, you just want to get a flashing. Yep, that one. And I want to intersect with, no, not that one, because that's going to give me a point down there, but with that one, that's going to give me that point. So I've got 36, 54. 54 would be the maximum cycling time. So I'd need to cycle in 54 minutes, but I'd need to run in 36. So I know that's 54 min max cycle. And now the maximum running time would be over here, because that's your maximum running time. So I'm going to go analyze, gsolve. I need to do another intersection. Scroll through that line and that line, and this is where we, which would be the maximum running time would be 60 minutes. Let's see how we went on that. This is question 6 by memory. So 50 and 54 minutes. Maximum run time, 50 minutes. So that's what we can see, which we did on the CAD. So we got that one pretty good. I think that's what I wrote, 50 and 54 by memory. I got 60 per cycle. Oh. Run, maximum run time. Maximum run time, I got 60. Let's have a look at that. Do we get 60 for run? Why have I got 50? Why have I got 50? Which is x plus y needs to be less than 90, which makes sense, which I've got y equals. Yep, which is the same graph. Maximum cycling occurs when y equals 1.5, which is that one. Why do I not have this? This should be 60-40. Oh, it's 50-40. I didn't read it right. Can't be 60-40. Plus 40 does that. So what I should do there, I did have it right. It is, yeah, it's 50 minutes. I didn't read it right. Hence, sorry, I was just overlooking that. Your y, let's see if we make that minus 20. I just didn't transpose it right from the calculator. If I go analyze, G-solve intersection, did exactly the right thing. I was just getting confused. Intersection, that was the maximum time. So we're going to scroll through to get the right graph. Execute to that one, execute to that one. It's 50, 40, 50, which you can't really see too well. But if I had my calculator, I'm sure I could. So 50, I was correct. Yes, good. That was making me worry, which doesn't make sense because it's 90 minutes. So I should always actually double check that and say, does that seem reasonable or not? So yeah, that's basically where we're at, guys. I'm going to leave that worksheet on there. What we're trying to do now